Hello everyone. Now we'll see joint probability distribution, chapter 5. So it is a very important chapter in probability, and it needs some knowledge in integrations as well. So the name says joint probability distribution. The distributed probability has link with another random variables. So joint probability distribution. So um, in this, we'll cover joint probability distribution for two random variables. It's like uh, up to now we have only one random variable and corresponding with probability of that random variable. In this chapter, we have two random variables. We'll take it as x and y, and how they are combinedly forms probability. So they both forms a new probability that is denoted with small f of x comma y, or probability of x equals to x comma y equals to y. Let us take an example. For example, this is x 1, 2, 3, and this is y, say a, b, c. So when x and y combinedly forms a probability, it will noted in a table. Like the example, like in our college at student center, there is most restaurant. There we have three different cups, three different sizes of cups: small, medium, and large. And for example, mm, uh, they serve three or four different items like guac, salsa, sour cream, and, and lettuce. So we can serve in three different cups and four different items. Let us take 100 samples. Like uh, for example, the first customer will take small size guac, will record it, medium size sour cream, large size lattice. So everything will record it as 100 samples. Like we'll calculate the probability of each one. So it will be noted in terms of table, like small, medium, large, guac, salsa, and sour cream, and finally lattice. So the combined small guac, how much we will get? Small size salsa, small size sour cream, small size lattice. So this is how we calculate joint probability distribution for two. So next is joint probability mass function. Simple. If x and y both are random variables are from discrete random variable, both are discrete, then it comes under joint probability mass function. It is denoted f of x comma y. That means, as I said, x equals to x, y equals to y, must be greater than or equals to 0. And when we sum up both, it must be 1. Next, joint probability density function. If x and y are continuous random variables, then f of x comma y is like, it will be integration from x0 to actually minus infinity to plus infinity, y equals to minus infinity to plus infinity, dx dy equals to 1. So what does it mean for joint probability density function? For example, if we plot a graph between x and y, On the top view, we will observe a region. The area of the region from the top view, when we plot between x and y, this is the area we calculated for probability value. So since it will have two different random variables, the f of x comma y. In previous class, we will x is a random variable on x-axis and f of x will be on y-axis. So we will calculate for x, we'll calculate for some values, we will join each other. This the area under the curve is probability. We have seen in third and second chapters, I mean fourth chapter. Whereas in fifth chapter, like it is like 3D. X on y and the probability is f of x comma y. We'll plot each diagram. It's like a cover which is like it is a 3D diagram. We will calculate some portion of the area by taking the limits. So it is really tough to calculate 3D diagram. So what we'll do, we'll take the top view of this diagram. So how it looks like, the top view x and y, it's something like a shape. So we will calculate this area. This area will give probability value. So by this diagram, you can understand it is a normal distributed joint probability. Okay. Next, a very important problem which Dr. Fred Sayari has taught in your classroom. So I have taken the same example, f of x comma y, 6 into 10 power of minus 6 e to the power of minus 0.01x plus. So since the function has both x and y, it comes under joint probability, that is two variable joint probability. The question is the probability function, like they wants to find out joint probability density function. So what joint probability density function? The joint probability density function is integration with respect to x and y. It will give equals to 1. Let us check whether it will give equals to 1 or not. So now integrate this function f of x comma y. So what is the limit here? Limit is 0, actually from minus to plus infinity, minus infinity to plus infinity. So we don't have calculated, so we don't have negative values in probability. So we'll calculate from 0 to infinity, plus 0 to 0 to plus infinity. So first we have, for every function, we will calculate the limits first. For x, it's 0 to infinity. So for y, it will be from x to infinity because they have given that x is always less than y. So there is no condition that for x, so that's why it starts from 0 to infinity, whereas y always y is greater than x. So it starts from x to infinity. That's why we have taken from x to infinity. These are the limits for x and y. So from 0 to infinity and x to infinity. What is the function? So I am taking out this constant to outside, e power of minus 0.001x minus 0.002 y dx dy. Okay, now I'm going to calculate for this y function. So x function 6 into 10 power of minus 6 e power of minus 0.x. So I'm going to calculate y integration 0 to y. This is dx and this is dy. So 6 into 10 power of minus 6, 0x e power of 0.001x dx. So integral e power of x is e power of x. So that's why e power of minus 0.002y from x to infinity dy. So it will become 6 into 10 power of minus 6 from 0 to infinity e power of minus 0.0001 x dx. When I substitute this one, so e power of minus infinity will be e power of like 1 by e power of infinity. So 1 by infinity is 0. So 0 minus e power of minus 0.002 x by 0.002. So after substituting this, we'll get 6 into 10 power of minus 6, 0, e power of minus 0.001 x. So e power of minus 0.001 x into 0, 0 minus, it will be, so minus minus get plus, again here minus, so 0.002 x dx. So finally 6 into 10 power of minus 6, the function will be 0.001, sorry, 0.003 x dx from 0 to infinity. So same, 6 into 10 power of minus 6 e power of minus 0.033 by minus 0.03 from 0 to infinity. After substituting the limits, we will get 0 minus 0.00 by 0. So 0.003. This is 0, so it will be 1. And sorry, here 0.002. We have taken out 0.002. I have taken that, right? Okay. So 0.002, 0.002. So 0.002. So 0.002 into 0.003 will give 6 into 10, 6 into 0.506. So it will be, both are, will cancel and will get 1. So hence it is proved that when we integrate a double integral of x comma y, we'll get 1. So you may see this type of table in your class. So what he has taken for 4 x y equals to 4 and x equals to 1, this is the probability value. So now the new concept called marginal probability distribution. Every time we listen about marginal means only one variable. For example, like before we have taken the function has x and y, both x and y. Whereas in marginal probability distribution, it will have only one variable. How? When we sum up all these values, you will get y equals to 4, the value of y equals to 4, like 0.15 plus 0.1 plus 0.0005 will give value of y equals to 4.3, like 0.17, 0.25, 0.8, and here 0.225. What is this 0.55 mean? P of x equals to 3. The entire P of x equals to 3. That is 0.55. I think you understand this one, like everyone, I think you might got this one, marginal probability distribution. Here there is no y. We have only x equals to 3, that is the value of 0.55. How? We will calculate the entire value of x equals to 3. This is called marginal probability distribution in discrete function. Likewise, here also, this is very, very, very important actually. Marginal probability density function for continuous random variable. For continuous random variable, simply like we have function f of x comma y. If I need f of x only one variable, I will integrate f of x comma y with respect to y. So if I need x where x function, only x function, I will integrate x comma y with respect to y. Similarly, f of y, if we integrate f of x comma y with respect to x, so we will get f of x, f of y. It will be more useful in further problems. Marginal probability density function, f of x comma f of y. So there is very important problem and it will covers everything. In this problem, we will find out y exceeds 2000 milliseconds. So he has given no limits for x. He has given only for y. Okay. So the condition is same, x is less than y. And another condition, y is exceeds means greater than, y is greater than 2000. So for example, if I draw a graph x and y, something it's similar. It is a graph between x and y. This is 2000, right? So he wants to find out this area above 2000. So I don't know about x. It might be less than x, x less than 2000, or else x is greater than 2000. So now I have a problem that I need to divide this area into two halves, like x, y, x, y. So this is 2000, this is 2000, this is 2000. Okay. This area and this area. Okay, I am dividing this 2000 above area into two halves because I don't know x limits. Now I know that from 0 to 2000, from 2000 to infinity. So I'll write down here another pen. So what is this area? X is less than 2000 and y is greater than 2000. And this area is x is greater than 2000 and y is also greater than 2000. So the limits will be like x is 2000 from 2000 to infinity and y is x to infinity. Since x is less than y, so y limit starts from x to infinity. For example, x is 3000. We can't take y equals to 2000. Since x is less than y, we will take from x to infinity. And here the limits are x is from 0 to 2000, as we can see this part, and y is also from 2000 to infinity. So there is no restriction here for x and y. So p of y greater than 2000, that is, I'm doing this like for I'm taking a is part A, part B. Part A is from 0 to 2000 and 2000 to infinity will minus 6 e power of minus 0.01x minus 0.002y dx dy. And B part, what is B part? From 2000 to infinity and x to infinity, 6 into 10 power of minus 6 e power of minus 0.01x minus 0.002y dx dy. So it takes much time to calculate these things. So it is easy if you know integrations. Simply first you can take either x or y, integrate it first. Later we can integrate another variable. And here we have to integrate first with y with respect to y. Later we will calculate integration with respect to x. So answer will be 0.0475 plus 0.0025. It is 0.05. So the understanding is important for here. Like he has given y is greater than 2000. Doesn't talk about x limit, but we only know that x is less than y. So I don't know about x. So that's why I had taken 2000 as a point where x is either might be x is less than 2000 or else x is greater than 2000. So in part A, I have taken x is from 0 to 2000 and y is same 2000 to infinity. Whereas in part B, the x value is greater than 2000 and y value is x to infinity. So, and next topic is mean and variance from a joint distribution. So, as we know that E of expectation of x is sigma x into f of x, right? Similarly, here also, expectation of x is integral minus infinity to infinity, like sigma is replaced with integration, x is same, and f of x. Here, I know x value, but I do not know f of x. How will get f of x? When I integrate f of x comma y with respect to y, I will get f of x. So this is marginal probability. Okay. Similarly, variance of x is also, we know that as f of x square, f of x minus mu square, right? Variance. So sigma, instead of sigma, I'll take integration x comma nu square whole square f of x x dx. So integral minus infinity to x minus mu whole square and do not know f of x. So I'll integrate f of x comma y with respect to y. So for this example, we know that this is 0.3, 0.17, 0.225. This is also important question. He might ask in this examination. So we will redraw this table to two halves for x and as well as for y. So for x, for what is the x values? 1, 2, and 3. For y, 1, 2, 3, 4. What is the value of p of x equals to x for y? This is 0 0.2 and this is 0 0.25, 0 0.55. Here also 0.28, 0.25, 0.17 and 0.3. So when I redraw this table to two halves, so it is very easy to calculate e of x, sigma x into f of x. Since it is discrete, I have taken summation. So 1 into 0.2 plus 2 into 0.25 plus 3 into 0.5. So similarly, here also variance is like 1 square into 0.28 plus 2 square into 0.25 plus 3 square into 0.17 plus 4 square into 0.3 minus mu square. So this is a mean and variance of joint distribution. Simply like he will give f of x comma y and we will calculate f of x or f of y by integrate it with respect to another variable. Later we multiply with x and we'll integrate it again after we multiply it with x. This is mean variance of joint distribution and for continuous, and this is for discrete. Conditional probability. Here also same thing for continuous random variable. So I'll give the example. Same question. 0.3, 0.17, 0.25, 0.28 and This is 0.2, 0.25 and 0.55. Okay. For example, I want to calculate P of Y. What is conditional? We should have a given function. Like we should know that a function. For example, if I know that x equals to 3. So this is x equal to 3. This is x equals to 3. This is also x equals to 3. And this is also x equals to 3. So this will consolidated into y equals to 4 given x equals to 3. That is this value. Plus P of y equals to 3 and x equals to 3. Plus P of y equals to 2 and x equals to 3. And finally, P of y equals to 1 and x equals to 3. So I have 1, 2, 3, 4 values with 1 x. So this is P of x equals to 3, I know that, and y equals to 4 given P of x equals to 3. Simple, as we know that P of A intersection, sorry, B, given B equals to P of A intersection B by P of B, like the denominator will comes to denominator and the function is and. So here also 3 and 4 and denominator is 3. P of x equals to 3. P of x equals to 3 and y equals to 3 with given P of x equals to 3. So P of y equal x equals to 3 and y equals to 2 with denominator P of x equals to 3 plus P of x equals to 3, y equals to 1 and P of x equals to 3. So P of 1, that is P of y equals to 1, this value and 3 value. This is 0.25 divided by P of x equals to 3. I know that 0.55. So denominator is 0.55 to everything 0.55. And x value is 3 and y value is 4. This is 0.05. This is 0.05 and 0.2. So we'll get around this is 0.454, 0.091, 0.091 plus 0.364 plus 0.454. We'll get, when we add this one, we'll get 1. Okay. This is conditional probability distribution for discrete. Now, conditional probability density function. Density means continuous. Mass function means discrete. You should remember this difference. Mass function is all about discrete function, discrete random variable, whereas density function is about conditional density function is related to continuous in this 5th chapter. So similarly, like f of x given x, it is denoted with f of y with given x will be f of x comma y by f of x. So again, marginal joint distribution. So we know this value, and how we'll get f of x? We will integrate f of x comma y with respect to y. So after getting this value, we'll substitute here some values will like cancelled, and we'll get f of y with respect with given x. Okay, it is where x and y are continuous here, and some conditions like f of y given x of with respect to y always greater than or equals to 0. When we integrate it, you'll get value 1. Like before also we got 1 because summation f of x, f of y given x equals to 1. Here integration f of y with respect to y is equals to 1. Okay. We'll calculate, determine the conditional probability density function for y given that x equals to x, and find the probability that x, and given that x equals to 1500. So This is okay. I'll stop here. So far, we have seen about joint probability distribution for two random variables, joint probability mass function that is discrete, joint probability density function that is continuous. And this is how it looks like when we plot a diagram between x, y, and f of x comma y. So it is difficult to find out for 3D. So we'll convert into 2D, like we'll take top view and we'll calculate the area, or I mean region between x and y. So we have seen a problem and marginal probability distribution for both discrete and continuous. This is very important. I think you got it every time. And when I need f of x or f of y only, we will integrate f of x comma y with respect to another variable. So this is very important problem. And mean and variance of joint probability, just we have consolidated this big table to two small tables. Directly we can calculate it. So conditional probability distribution with discrete and conditional probability density function formulae. So in the next section, we'll see this problem, the conditional joint probability. Thank you.